Yes, today I'm gonna show the instantaneous war compensator. So in this part we will see the turn on procedure and connection procedure and the turn on with the open loop mode with RL load. Okay, so now as per part 1 I have connected the grid here RYB, then connected the output of the source unit RYBN to the control unit, okay, RYBN, and here I have connected the load, so RYBN to the load unit RYBN. Now turn on the MCB1, turn on the switch 1, okay, with RL, okay, turn off the load 1 first, okay, then you can turn on the control unit first, okay. So here you can see the display. So here first we have given the protection. So once you can get the greater than 20 volt, then this protection will be off, okay. So the supply is not there, okay, and you can just see everything is healthy. Then this red LED, green LED will be indication the ready, okay. And here you can just see the source unit. So now I have given the grid voltage here, okay. So now turn on the grid, okay. So by using this switch you can turn on the supply, okay. Just so you can just see if all the three phases are healthy, then these three indications are there, RYB indications are there. And here you can see the voltage, RYB voltage, line voltage, okay, the RYB voltage, line voltage, phase voltage, line voltage, current, okay, power, kVA, kVAR, and power factor. Here at the power factor we have locked the display, so long press to this button, then you can just lock this display to power factor, okay. Now go to the control unit, okay. So now you can just see once I have turned on the supply, okay, so the protection will be deactivated, okay. And here you can just see the mode is open loop mode, select mode means open loop mode, and phase voltage is 60 volt, okay. By pressing this button you can just change the open loop or closed loop mode, okay. So and here we have connected the MCB or turn on the MCB1 RL load we have selected. Here we have just see, okay. Now you can just turn on the supply, turn on the control by pressing this button, okay. So you can just see the on status are there. IQL means load current, IQ load current we have seen on the display, IQR and IQ are also there. Now it is 0 okay. IQL -4, VDC we have regulated at 200 volt, okay. Now you can just see the power factor is 0.95, okay. Now we can compensate this power factor to 0.99. so the RL load are there, okay, RL load are there. So you can just increase the IQ value, okay. By pressing this button you can increase the IQ value. So one I have pressed the only once, okay. So IQ value is 0.5, okay, 0.5 IQ value I have given. So you can just see the compensation are there, and you can just see the power factor is corrected, and now power factor is 0.99, okay. Almost the unity power factor are there, and also you can just see here, okay. VDC is also regulated at 200 volt. IQR also maintained here. Open loop mode on. IQL compensation is -0.4, okay. ID is 0.1, okay. So likewise this you can control it, okay. Again you can just turn on, means you can increase the load. So the power factor is now getting the poor, so I am increasing the load. So you can just see the IQL is now increased to -1.3, okay. And also you can just see the power factor is now poor, and it is going to 0.92, Okay, 92, 93. So now we will increase the IQ, okay, and we can compensate the power factor. Okay, so IQ is now 1. Okay, now you can just see the power factor is 0.98. So again we can increase the IQ reference, so you can just go to the unity power factor. Okay, so I am increasing this, so IQL is minus 1.3, IQ and IQR is matching to 1.5. okay, 1.2, 1.5, OEDC 200, ID 0.0 or 0.1. okay, so now you can just see the power factor is 0.99. okay, so likewise this, the in the open loop mode with RL load we can compensate the power factor by increasing the IQ reference. Okay, now we will see the waveform of the voltage, current, angle like this at the control side, and also we can see the waveform of the compensation voltage and current, means unity power factor it is maintained here na. So voltage and current is at the in phase, we can observe from this test point. Okay, so now I have connected the DSO at the deck point. Okay, so here my deck 1 is the voltage and deck 2 is the current. Okay, so you can just see once the my load is the RL load, so the current is at leading side. Okay, so you can just see, we can observe the current is at lead. Okay, now you can just increase the voltage and current amplitude and you can just see the performance. Okay, now we can just see, remove the one load. Okay, turn off it, then you can just see the load performance. Okay, and also you can just see the current power factor is now poor. Okay, now you can just reduce the IQ reference, because we have increased with both load we have increased the IQ reference na. So we can just reduce the IQ reference first. Okay, so here I have reduced the IQ reference to 0.5. okay, so you can just see the voltage and current. Okay, and also you can just see the power factor is 0.99. okay, so likewise this you can observe your current and voltage. Now we will see the voltage and current at the source side. Okay, so now I have connected the DSO at the input side. Now we can see the compensation. Okay, so voltage and current are in phase, so you can just see the voltage at the channel 1 and current at channel 2. Here we can see the power factor is 0.99, so you can just see the performance. Okay, so just see the voltage at the channel 1 and current at channel 2, and it is almost unity. Okay, just you can just observe it. Okay, now I will change the load or I will increase the load. Okay, so what effect we have done on the voltage and current, okay, we will see. Okay, so now power factor is poor, so you can just see the power factor is around 0.92. so also you can just see the load is the RL load, so the voltage the current is lag. Okay, current is lag from the voltage, so you can just observe at this point. Okay, now we will compensate this by increasing the IQ reference. Okay, so I am increasing the IQ reference to 1. Okay, so just observe the compensation. Okay, it is almost 0.98. okay, now again I want to increase this IQ reference, so it is around the unity power factor. Okay, so now again I am increasing the IQ ref. Okay, so now you can just see the compensation is done, and you can just see the unity power factor are there. Okay, so on the display also you can just see the unity power factor are there. Okay, and here the voltage and current are in phase. Okay, also we can observe the frequency 50 hertz, power factor 0.9, kW 03, total. Okay, average, max, voltage, current, okay, current, max, average, total. Okay, so here also you can see the power. Okay, so almost 0, and kVAR also 0. Okay, so likewise this you can measure all the parameters from here. Okay, again you can lock it by pressing long press of this. Okay, so likewise this you can increase or decrease the load, and you can compensate the current. Okay, and also you can just see I am decreasing this compensation current. Okay, so now my compensation current is almost 0. Okay, my compensation is now 0. Both the loads on, and both the resistive load is on, and the RL configurations are there. So my power factor is poor, 0.8, and you can just see the voltage and current, so it is lag. Okay, current is lag from the voltage. Okay, so likewise this you can observe the performance, you can observe the waveforms, and you can perform your practical with the open loop RL load. Okay, thank you.